Hey guys, Mr. Brighting back here for the third lecture in energy and motion. And I am continuing down the physics talk. And again, it's the only physics talk for this unit. Lucky you guys. Um, so, pretty much you guys should have done the investigate. And the investigate is kind of a way to look at pole vaulting. And in this part of the physics talk, so I want a square. I want to go around this thing in a square. In this part of the physics talk, it's going to be going over that idea and it's connecting it to the conservation of energy. When you guys did the quote unquote pole vault in the investigate, there were a lot of energy transformations. Now, the first one, in fact, they don't even list it until down here, um, is the fact that you eat food. You take that food, and your food actually has what we call chemical energy. That chemical energy is then used by our bodies, and it's turned into mechanical energy. All right. We do work on. We did work on that little ruler. We pushed it down. Okay, a force over a distance. And because it was a force over a distance, and now the object is still, it probably has some sort of potential energy, and that potential energy is called elastic potential energy. And it's a lot like gravitational potential energy, except it rather than it being in a position above the Earth, it's like it's in a position um, on the ruler. So now, when we let go of the ruler, all of that stored work, that energy, elastic potential energy, is in essence released and it's turned into kinetic energy. That kinetic energy is, so we have the ruler, we push it down, and then it flings that quarter upward, okay? And that quarter begins to gain potential energy again. Okay, so it has a bunch of potential energy at the bottom from the ruler. The ruler pushes it up over a distance, work, and that work becomes kinetic. That kinetic then becomes potential, and guess what the potential then becomes again? The, the potential then drops down, and as the quarter drops down, that potential becomes kinetic energy. So just in that silly little investigate, you saw tons and tons of energy transformations. Yet, in all of those energy transformations, no energy is actually lost. It simply transforms from one type to another. Now, of course, in a perfect world, those transformations are perfect. But in our world, you think about that ruler, and whenever it's bent, actually, some of the energy becomes thermal energy in the ruler. So if you were to take a pen and bend it back and forth a bunch of times, you can feel the pen getting hot. When the quarter goes up, there's friction with the air, or air resistance, also known as air resistance, and so that slightly heats up the air a little bit. So again, this potential energy at the bottom, a very small portion of it becomes thermal energy, but most of it becomes kinetic. And then that kinetic becomes potential, and then the potential is dropping down, and it's becoming kinetic, and some of the energy again is turning into thermal energy because of the friction. All right. Let's see. Anything else I need to talk about here? I don't think so. So again, I already talked about the food energy. The food energy again, it's called the um, chemical energy, and our body breaks down the different bonds of atoms. Atoms are bonded together, and it breaks down those bonds and creates new ones and gets a whole bunch of energy from that. But you'll learn a lot about that whenever you do chemistry. But overall, here's what I want you to see is the fact that when you did the investigate there, you were doing work by pushing down the ruler. The ruler then had potential energy. That potential energy, again, the ability to do work, did work upward, and pushed the quarter through the quarter up, giving it kinetic energy. That kinetic energy then was slowed down by gravity, becoming potential energy. The potential energy then started to go, or the quarter started to go downward. The potential became kinetic energy. All right, so lots and lots of energy transformations. If you have any questions on this lecture, I know it was very wordy, make sure you write down any questions. Other than that, I'll see you guys next time.